Hey folks, welcome to the first video of chapter 4. And so in this section, we're going to take a look at 4.1 probability distribution function, or PDF, for a discrete random variable. Okay. And the key point or the key takeaway for the two examples we're going to do in this video are what make a discrete probability distribution function. Okay. So that's really the takeaway skill from this. All right, so let's read through example 1. A hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. And so we can see that we've got some information in a chart over here, okay? And now there's an X and a P of X, and in our problem, it tells us what those things are. So it says, let X be the number of times the patient rings the nurse during a 12-hour shift. For this exercise, it turns out we were counting either 0 times, 1 time, 2 times, 3 times, 4 times, or 5 times in a 12-hour shift, okay? So I'm just going to write that over here, that this X is actually the number of times a patient rings for the nurse, okay? So X is the number of times a patient rings for the nurse, and then P of X, this other column, is the probability that that will happen, okay? So if we look at this, we see that 0 number of times that a patient rings for a nurse, the probability that that's going to happen is 4 out of 50. And what that means, because we looked at 50 patients altogether, is that 4 patients actually rang the bell for the nurse 0 times, okay? And if we look at the second one, it says P of 1 is 8 over 50. And what that means is that 8 patients out of the 50 rang the bell 1 time for the nurse during the 12-hour shift, okay? And if we kind of keep going, we see that 16 patients rang the bell 2 times, 14 patients rang the bell 3 times, 6 patients rang the bell 4 times, and then there were 2 folks who rang the bell 5 times in a 12-hour shift, okay? And so if we look at this, what this is telling us is that most of the patients rang either 2 or 3 times, right? 16 out of 50 or 14 out of 50. But this question is asking us, why is this a discrete probability distribution function? And in our textbook, they give us 2 things that we need to look for so that we know something is a discrete probability distribution function, okay? And so I'm going to write over in this space over here, just so we can see it. But in our textbook, it said we need to look for 2 things, okay? The first thing is that all probabilities are greater than or equal to 0. And if we look, we have 4 out of 50, 5 out of 50, 16 out of 50, 14 out of 50, 6 out of 50, and 2 out of 50. And all of these probabilities are greater than or equal to 0. And so what that means is we have confirmed the first part of the reason why this is a probability distribution function, okay? Now, the second thing we need to look for is that the sum of all probabilities, when I add them all together, I actually get 1, okay? Now, we use a symbol here for sum that I want to make sure we're familiar with, okay? It kind of looks like a pointy E, all right? So most textbooks write it something kind of like this, all right? And that is a symbol called sigma. And it's a math symbol we use to say the sum of things. So we're adding together a bunch of things, okay? Now, I don't usually write it this way. The way I write it is kind of like this, okay? So same kind of idea, that when I add all of my probabilities, I should just get 1, okay? So let's do that. Let's add all of these together and see if we get 1. So 4 out of 50 plus 8 out of 50 plus 16 out of 50 plus 14 out of 50 plus 6 out of 50 plus 2 out of 50. And we can certainly use a calculator for this, no shame in that. But I notice that all the denominators are the same, which means I just need to add all the numerators, okay? And so 4 plus 8 is 12, plus 16 is 28, plus 14 plus 6 plus 2. And if I add those all together, I will get 50. And we know 50 divided by 50 is 1. And so that shows that the sum of all the probabilities is 1. And since it fulfills these two conditions, we have a discrete probability distribution function. Okay? All right, now I'm going to go over one more example. And in this example, we're going to be given probability not in the fraction form, but in the decimal form or in percentages. Okay? But we're going to look at sort of the same idea. Okay, example 2. Jeremiah has basketball practice 2 days a week. 90% of the time, he attends both practices. 8% of the time, he attends one practice. And then 2% of the time, he doesn't show up to either practice. What is our X and what values does it take on? Okay. And so if we want to think about that table from above, really, it would be important for us to have our X and our P of X, okay? And if we think about what we're counting here, we're looking at he goes to both practices, or that's 2 practices, 1 practice, or neither practice. And we usually we list those in order from biggest to smallest, okay? So there's sometimes he goes to no practices, sometimes he goes to 1 practice, and sometimes he goes to 2 practices, okay? Now, what percentage of the time does he go to no practices? Well, we can see that that's 2% of the time. And so we're going to write that as 0.02. Remember, we divided by 100 to get the percent. 8% of the time, he attends only 1 practice. And so P of X, when X is 1, is just going to be 0.08. And last but not least, 90% of the time, he does attend both practices. So 90 divided by 100 gives us 0.9, okay? And so what is X and what values does it take on? We can say X represents the number of practices that Jeremiah attends. Right? The number of practices that Jeremiah attends. And what values does it take on? 0, 1, or 2? Because he either goes to no practices, he goes to 1 practice, or he goes to 2. They only have 2 practices a week, so we can't get any numbers higher than that. Okay? Now, if we wanted to double check that this is indeed a discrete situation, right? Like if we go back up here, we want to make sure that this is a discrete probability distribution function. Are all the probabilities greater than or equal to 0? And do they all add up to 1? Well, let's check. Okay. I notice that all of these values are greater than 1. And if I add my P of X all together, I'll get 0.02 plus 0.08 plus 0.9, and that gives me 1, which means this is indeed that discrete probability distribution function, okay? So I'm going to go ahead and highlight this discrete probability distribution function, because that is sort of the theme of 4.1, okay? We just want to be able to recognize that. In 4.2, we're going to take a look at some different stuff, but that's the most important thing for 4.1, okay? All right, thanks so much for stopping by. Let me know if you have any questions.